In this video, I'm going to talk about the iodine clock reaction for general chemistry lab. And so what we're doing is we are looking at this first reaction we have up here. So this reaction we have up here, but the thing that sort of complicates this sort of conceptually is that we are coupling it with this reaction here. And so what we see is that we have this persulfate ion here, and we are reacting it with these iodide ions here. And then it's generating these sulfate ions here in iodine. But this iodine, which will react with starch, as we see down here, to generate this complex that looks like this, that changes the color. But we are coupling it with this second reaction here, where we see this iodine right here is now being used as a reactant in this reaction. And we are reacting it here with this thiosulfate ion. And then that returns it back to the iodide ion here, and then we end up with this species right here. And so this iodine here is what reacts with the starch down here, and so that's what causes the color change. And so the second reaction, which occurs faster than the first reaction, is removing these iodines here. And so that allows us to sort of halt or pause the change of color until all of this S2O3 is removed. And then once that happens, the color changes, because then this iodine isn't being taken away, and so it can react with the starch here, or it can associate with the starch here and cause that color change. And so an analogy I thought of is, say we had person 1, we had you, and we had person 3 here, and person 1 is passing you $1 bills here, but as soon as they pass it to you, you then pass it to person 3 here. And so you are ending up with no money as we do this. But say after $100 has been passed to you, then you stop passing it to person 3. Now all of a sudden you are acquiring these $1 bills. And so you could think of, before you stop accumulating this money, you're passing it to person 3, your happiness is sort of not changing at all. But as soon as you start accumulating the money, then you start becoming happy. And so that's kind of what's going on here, where we can think of the color change as happiness here, where this this species right here is sort of taking this iodide here and passing it to you, so you have this I2. But then this species right here, this thiosulfate ion here, is taking those I2s and then giving it to somebody else. But once all of these have been taken up, then the iodine can start accumulating, and so that would be like the money accumulating to you, and so that causes the color change and makes you happy. And so that's kind of the conceptual part of what's going on here. What we actually do in the lab is we're mixing all of these things right here. So we have our sodium iodide here, we have our sodium chloride, we have our sodium thiosulfate there, we have our starch, we have our potassium sulfate, and then our potassium persulfate right there. And we see what I have here in red are the changes here in the concentration of the different species. So the sodium iodide here is our different species of the iodide ion. And then right here we have the changes in our species of the persulfate ion right here. And so changing those concentrations will allow us to look at how the different concentrations of these things affect the rate of the reaction. And so that is sort of what we are looking at. In the lab, you sort of mix these things together from left to right down this table. So we go left to right down this table. And when we get to this last one here, because this is sort of the I guess the business end here of this reaction, what you do is, and this is important, is you want to mix this together and then quick shake it up and then put the rubber stopper onto it, because you want it shaken up so that you have a homogeneous solution there. And so it's important that when you get to this last step, when you're mixing this last thing here, that you are mixing it and then quick putting the rubber stopper on and shaking it a few times so that you homogenize the liquid for it. And then you will sit and watch the reaction, and it will occur very quickly, or it'll sit there doing nothing for a little while, and then all of a sudden it'll happen quickly, and you will want to get the time it takes. So you'll want to start the timer when you mix this last ingredient here, and then stop the timer when you see the color change. We can actually see here on the iodide or iodine clock reaction on Wikipedia what this reaction will kind of look like. So we start this, see they add that to it, it sits there for a minute, and then the color changes really fast. Okay, so then after the lab, we have the post-lab stuff. So we will be answering the post-lab questions. And so the first one is finding the rate. And so that is why we need the timer on this, because we have the timer here in our denominator. And the reason that we are doing sort of that coupled reaction is because we can look at the change in concentration here in the numerator. And so we know the concentration of our thiosulfate ion, and so we can use that as the concentration in the numerator there. Then we will find the reaction order, and so that's looking at the rates. So we have our rate for 2 and 1 here. We have a rate for reaction 3 and reaction 1 here. And so remember that these are the 3 reactions we have going on down here. So we divide those, and then we can solve for the x and y here, and that will tell us what the Q and R will be. Then the next question will be looking for the initial concentrations, and so we will be using the dilution formula here and looking at the volumes here. And in the table in the book actually has the concentrations for all of these things here, which will be 0.2 molar for each of those. And so that's what we will be using for the M1, V1, and M2, V2 on that. Then we will want to find the rate constant, and so for that we will be using the rate equation. Then we will be looking for the activation energy. So the first three experiments in this will be just looking at this in general. Then the fourth and fifth will be looking at it at a higher temperature, and then another one will be looking at it with a copper sulfate added to it, which will act as a catalyst. And so for all of these, we can use this Arrhenius equation here to find the activation energy, which is up here in this exponent there. And so those are the sort of post-lab questions that we will be answering. But before the lab, kind of the thing to know is understanding this right here, this sort of coupled reaction we have going on here. I think that's going to be kind of a big tripping point for a lot of people, what's going on with that coupled reaction there. So make sure you understand that, and that you understand in the lab sort of all of the things that you have to do. So mixing these things, and then this last sort of important step here of mixing this and then quickly quickly putting the rubber stopper on and shaking it, and then at the same time you are starting the timer, and then you will stop the timer when you see the color change happen. And so those are kind of the important things, and reading out of the lab notebook will be important for really getting an understanding of these things. So make sure that you do that before you go to the lab. And I hope you found this video helpful, and I will see you later.